Pluto is a distant and subtle, more humble planet that was once a piece of our nearby planetary framework. However, recent significant statements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a dazzling revelation. They suggested that this cold world is on a potential impact course with Neptune. But how could this happen, and what might be the consequences of such a titanic event? Are we witnessing a captivating infinite oddity, or is there something more to this looming cosmic calamity? Join us as we analyze the potential outcomes of a Pluto-Neptune collision. Pluto, a former planet that was later reclassified as a dwarf planet, remains a subject of fascination and focus in the vast universe. According to recent evaluations by leading experts, Pluto's orbit is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku have raised alarms about a potential hazardous collision between these two planets, which could pose a significant risk to Earth. But how is such an event even possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It takes an extraordinary 248 years to complete a single orbit, and since its discovery in 1930, it hasn't even completed one full revolution. Pluto's orbit is marked by its unusually elongated shape, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more remarkable is its inclination, tilted at 17 degrees to the ecliptic plane. This tilt and eccentricity add layers of complexity to its orbital arrangement. One of the most intriguing aspects of Pluto's orbit is its intersection with Neptune's. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their positions in the solar system. This raises the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to decipher its unique path. Unlike other planets, whose orbits lie mostly close to the ecliptic plane, Pluto's orbit stands out with its steep inclination and elliptical shape. The stability of Pluto's orbit amidst these complexities is evidence of the intricacies of celestial mechanics. The three-body problem in space involves determining how three objects, like Pluto, Neptune, and the Sun, move and influence each other with their gravity. It's like trying to predict where they will go based on where they started and how they pull on one another. In Pluto's case, this problem illustrates how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. Terms like non-synchronous libration, orbital precession, and VZK oscillation are crucial in this puzzle. According to astrophysicists, what keeps all planets in their orbits is non-synchronous libration. In the case of Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it is positioned about 90 degrees away from Neptune. This spatial separation is vital in preventing their orbits from merging. Orbital precession, on the other hand, refers to the vertical movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, adding an extra layer of protection from potential collisions. Another critical factor is the VZK oscillation, named after three scientists who studied how objects move in space. It involves the way three celestial objects, like Pluto, Neptune, and the Sun, pull on one another with their gravity. This gravitational tug influences how they move. Despite Pluto's path seeming unusual, this oscillation helps keep it moving smoothly over long periods. The VZK oscillation demonstrates that although things in space may seem chaotic and unpredictable, certain patterns and rules keep everything in balance. These factors help maintain Pluto's orbital stability, ensuring that it doesn't collide with Neptune or veer off course. The three-body problem is essential in understanding how these orbits evolve due to the gravitational interactions between celestial bodies. Understanding Pluto's orbit is critical, especially given discussions about its potential collision with Neptune. While current models predict a stable orbit for Pluto over billions of years, they rely heavily on the accuracy of initial conditions. Even minor changes in these conditions could lead to vastly different outcomes. Astrophysicists like Neil deGrasse Tyson and Michio Kaku have recently raised concerns about a potential collision between Pluto and Neptune. Despite the intricate gravitational dance that keeps these planets apart, the possibility of external disruptions, such as a passing star or the shifting positions of Jupiter and Saturn, could upset this delicate balance. The future remains uncertain, and any shift in this finely tuned resonance could have significant implications for Pluto's orbital trajectory, potentially setting the stage for a dramatic outcome. Heavenly bodies communicate over huge spans of time. These models incorporate factors like the gravitational impact of Goliath planets, the slight draws of other trans-Neptunian objects, and even impacts from far-off stars or galactic peculiarities. Through these reenactments, astrophysicists have had the option to unwind a portion of the complexities of Pluto's orbital elements. Yet the vulnerability stays in the more extended-term forecasts. One of the main inquiries is the manner by which Pluto's situation fits into the more extensive story of the planetary group's development. Its current circle and status as a Bantam planet recommend that it very well may be a leftover of the early planetary group, maybe a part of the Kuiper belt that never converged into a bigger planet. The Kuiper belt, a huge area of frosty bodies past Neptune, is home to numerous items with comparative properties to Pluto. Concentrating on these articles assists researchers with understanding the developmental history of the planetary group, including how the monster planets shaped and relocated to their ongoing areas. Should a Pluto-Neptune crash at any point happen, be it through a possible interruption of the gravitational reverberation or an unexpected, outside cosmic occasion, the results would be cosmic and broad. The effect would almost certainly make a tremendous arrival of energy, modifying both planets' structures and conceivably sending garbage into space. This trash could turn into another source for meteoroids or even structure a transitory ring framework around Neptune. Such an occasion would reshape our comprehension of planetary crashes, their results, and their effect on the planetary group. In spite of the sensational prospects, the probability of a Pluto-Neptune crash stays minuscule. The complex gravitational elements that have kept up with their security for billions of years show no undeniable indications of disappointment. Nonetheless, astrophysicists keep on checking these developments, not just out of logical interest but as a feature of a more extensive exertion to comprehend the dependability of planetary frameworks and the possible dangers to Earth from far-off divine occasions. Pluto's story, from its disclosure to its downgrade to a Bantam planet, and the ceaseless discussions about its orbital conduct, addresses the always developing nature of space science. It is an update that the universe is an intricate, dynamic, and frequently capricious spot, where even the littlest articles can have a huge effect on our comprehension of grandiose mechanics. As we proceed to notice and investigate the planetary group, new advancements in innovation and science will probably reveal more insight into the subtleties of Pluto's circle and its connection with Neptune. The idea of a Pluto-Neptune crash might appear to be far-fetched today, yet it fills in as a brief look into the mind-boggling elements of heavenly mechanics and the need for continuous investigation. The excursion to comprehend Pluto's spot in the planetary group is a demonstration of mankind's interest and our hunger for information about the universe we call home. For the present, Pluto keeps on wandering on its grandiose way, a little yet convincing piece of the fantastic riddle of our planetary group. Whether it at any point experiences Neptune or keeps on captivating us from a good way, it stays an image of the marvel and secret that space holds for us all.